So in today's lesson, we're going to be talking about topic 0.6, which is inverse trigonometric functions. As always, make sure you are writing your last name and your first name. So make sure that goes up at the top of every page. And then you need to fill in your essential question, your I can statement. So our essential question is, how do you evaluate the inverses of trigonometric functions? And the I can statement is, I can solve for the angle in any trigonometric function. And as a reminder, you can always stop the video and pause to write down anything that you need to. Also, make sure you have 2 comments or questions in between your essential question and the summary of the notes. Before we get into the inverses, because you see there's some graphs here, we haven't yet talked about graphs of trig functions. You are going to do a little activity, at least exploring them here in a day or two when we have an asynchronous time. But I'm going to just want to talk through them really quickly. So this is a picture of a sine function, okay? It's a wave, and the biggest thing you need to understand about sine is that it starts at 0. And notice it doesn't go any further than 1 or anything below -1. There are ways to make it do that, but notice it's a wave that goes between -1 and 1, okay? Let's compare that to cosine. So there's your cosine graph. I'm going to take the sine off a little bit. It will, in relation to sine, cosine starts up at 1, and then it's a wave, okay? And it goes still between 1 and -1. So the 2 things you need to remember about sine and cosine, because sometimes in calculus we do have to identify them, okay, is sine starts at 0, cosine starts up at 1, okay, and then they're the wavy graphs. So I'm going to take my cosine off. I'm going to put cosecant on. Sine and cosine are the ones we see the most, okay? So there's the cosecant. Remember how it was the reciprocal of sine? So the reciprocal of sine, sorry, so see how it looks like the u part of the graph flipped? Well, just like we would flip a reciprocal, okay? And you'll notice that there's some spaces in here. These spaces in here are what we call asymptotes. I could put on a line x equals 0. And do you see how that's an asymptote right there? All of these asymptotes are occurring at values actually on the unit circle, okay? All right, I'm going to look now. I'm going to take sine and cosine off, or cosecant off, and I'm going to put cosine and secant on. And you notice cosine and secant have the same relationship that sine and cosecant do. They're reciprocals. We flip and we get the u's. So the repeated u looking graph is either got to be the secant or the cosecant. And you know the difference because one starts up at 1 and one starts down at, let's look at the cosecant here. And then the cosecant, it's shifted a little bit. Okay. All right, let's look at tangent. Tangent, if you look at it a little bit narrow, it kind of looks like a heartbeat, but it kind of looks like a cubic function that's repeated. And again, just like in cosecant and secant, it's got asymptotes, okay? Now look at that compared to its reciprocal cotangent. Cotangent just basically tips the other direction. So the way I like to think about this is tangent has like a positive, it's an increasing always, and cotangent is negative, it's always decreasing. So what we're going to get into today are the inverse trig functions. So you'll notice that the sine function, it goes always. Look at the inverse trig function. It's called the arcsine or sine inverse. Notice it stops, okay? And we're going to talk about this in this first part here. It does not keep going. It has a restricted domain is what we call that. Okay, so it'll make sense here in a minute why I'm doing something. The cosine, look at the arc cosine graph. There's the arc cosine graph. Again, it's a restricted domain, but it's a different restricted domain than sine was. And let's look at arctangent. We're not going to do the additional 3. So there's tangent, there's arctangent. Its domain's a little bit different, but you'll notice that it definitely levels out. It does not go beyond certain y values, okay? So I am going to go ahead and we're going to flip into notes here and we're going to explain this first part, okay? So the inverse sine function is defined by y equals arcsine if and only if sine of y equals x. So really what this is saying is if I have that y equals arcsine of x. I have to have a way of reversing that, and I should have given myself some more space there. So in order to reverse an arcsine, I'm going to take the sine of both sides. Well, what this is saying is that the sine and the arcsine basically cancel each other out. So the sine of y equals x. So you can see that's where that came from. But notice it's restricted to -1 to 1, and for the y value, it's restricted from -π/2 to π/2. So that means that I'm counting from here, -π/2 all the way to π/2. And the reason they're doing this is because if we were here and we were at 3π/2, it wouldn't make sense to count 3π/2, 5π/3, and so on to get to π/2. It makes more sense to count from -π/2, -π/3, -π/4, -π/6. You may add these to the unit circle, okay? You can add those radian measures, and then 0, and then π/6, π/4, π/3. So that counting method makes more sense than starting from 3π, because you get an actual set of numbers that's in order. If I was starting here, it doesn't make sense. So the domain of the arcsine is -1 to 1, and the range is -π/2 to π/2. So this works for arcsine, arccosine, arctangent, but notice your domain restrictions are a little bit different and your range restrictions. So that means they're going to be valid in different quadrants. So this is the quadrants that they're valid in. So this is saying because it's between -π/2 and π/2 that it's only valid in quadrant 1 and quadrant 4. And the reason for this is then, like yesterday when we were looking at the lesson, there were times when we had repeated values. This is going to restrict it to one value. For cosine, if I were to go here, I'd have they'd both be positive cosine values. So in order to make it one positive and one negative value, cosine is in quadrants 1 and 2. That's how I get from 0 to pi. And then arctangent is the same as arcsines, because I really am looking for having one positive value and one negative value. It's valid in quadrants 1 to 4. And then they also show us the pictures there.